Hey, it worked. All right, first try. All right. Hi, y'all. I'm Robert. I'm here to talk about Isograph. Isograph is a framework for building React apps that are powered by GraphQL data. But it has ambitions to be a framework for building apps that are powered by data. So I just want to get a sense of the room here. Who here has heard of GraphQL? Awesome, most people. Who here has used it? Okay, that's pretty good. Who here has heard of Relay? Yes. Oh, that's great. Okay, awesome. So Isograph is very much a work in progress. I just released the alpha version of it in January. Please give it a try. Tell me everything that's wrong with it, and let me know any feedback you have. But even though it's a work in progress, I'm still super excited to share it with you, even in its current state. So why am I so excited? I'm excited because Isograph, I think, has the possibility of providing the absolute best developer experience for app developers. And I'm not just saying that, I actually mean it. And in particular, Isograph has you structure your apps in a fundamentally different way than any other framework. It gives you a different building block, which we're going to call client fields. Not the best name. I'm totally open to suggestions for what this could be called differently. This abstraction, it eliminates a lot of the boilerplate of working with GraphQL. And in particular, it allows you to have sort of the ability to reason locally while building apps that are out of the box, performant and stable, and allows you to sort of move fast. So I could also tell you that I'm excited that Isograph, the query language, gives you precise control over when and where you show data to the user, meaning that Isograph apps are going to be good fits in places where GraphQL apps are not. Or I could tell you that Isograph gives you the high-level tools to make certain interactions that are present in every app, but whose details are hard to get right, trivial. But those are just added benefits. The most important thing is how it has you structure your app. Okay, so let me explain what Isograph is in a sort of extremely high level. With Isograph, developers write components along with their dependencies. So in particular, a dependency might be something like a GraphQL server field, like a user's email, or it might be something like another Isograph component, such as a link to the user's detail page. On every save, the Isograph compiler scans your code base for these Isograph literals and generates a bunch of files. These files might include things like a query that will fetch all the data for a given page, or a bunch of TypeScript types, or some sort of internal data structure that's used to connect all the parts of your app so that you don't have to do that boilerplatey connection work. These files are then used by the Isograph runtime to show you what you want to display to the user. So the TLDR is that Isograph relies heavily on a compiler and on generated files to give you great performance, stability, and great developer experience sort of out of the box. Okay. So Isograph uses the tagline, the UI framework for teams that move fast without breaking things. This raises the question, why is it so damn hard to move fast without breaking things? And I mean, it's not, right? On my side projects, I make a little change here, make some changes there, and bada bing, bada boom, I can ship it, and I know roughly that it's going to work. But you go to work and it's design review this, why'd you break production that, like post-mortem, planning document, blah, blah. It's boring, it's bureaucratic, it's frustrating, it's soul-sucking. So what's the difference? Well, the difference is that at work, the app is too large to fit in a single person's head. So there's a lot of communication and coordination that's required. You make some changes that work locally, maybe the unit tests pass, and you ship, and it still breaks production. And so this is also paired with a lack of contracts. In particular, there's a lack of things that prevent you from breaking production. So companies respond by slowing down, by adding manual review processes, or they can architect their app in a way that every piece is independent. So you might imagine a series of microservices that can be independently deployed. Or in the web development context, you can imagine a web app where every single component fetches its own data. So that's pretty good. Like, you can reason about one file, as long as it works, you are safe to ship to production, and your overall app doesn't break. That's pretty good. But it comes at a cost, which is that, at least for the web app case, you're making a lot of redundant network requests, and the backend is hitting the database for the same fields over and over. So there's a lot more load. And the loading states that you show to your user, they're a bit ad hoc and chaotic. They're dictated by how you broke your app up into subcomponents rather than what's best to show the user. And lastly, you're architecting in a bunch of network waterfalls. So you might imagine an outer component and an inner component. The outer component's network request has to complete fully before we even start the network request for the child component. So you're showing the data that the user cares about later than you otherwise could. That's not ideal. Okay. Alternatively, what we could do is we could write one query. This is kind of nice. There's one loading state, there's implicit deduplication, there's pretty good performance. It's kind of nice, but the problem is it's brittle. You come back to this page a few months later, things have changed, you don't really remember how everything works, and your product manager tells you, make this change to a component, we no longer need to use the Instagram URL field. Okay, you make the change and you go to the query declaration, and can you remove the Instagram URL field? It's really unclear. You have to do a lot of research. You have to find out, is any other component using the Instagram URL field? So types can help here, but on the other hand, what if a component is using that field in a way that's not tracked by the type system? So for example, through json.stringify or object.keys. Or what if somebody lands a component at the same time that starts to use that Instagram URL field? So at this point in time, you have a choice to make. Do you try to make your app like 0.001% more efficient and risk breaking production? I don't know about you, but I probably would not. And this problem is compounded by the fact that components are shared across multiple screens. So it's really a lot of work and a lot of mental overhead to reason about this. So over time, these query declarations, they sort of act as like append-only documents. They're filled with fields that may or may not be used. Nobody is brave or stupid enough to try to remove them. Okay, so I hear what you're saying. There is a technology that can solve this, and it's called GraphQL. And you're 100% correct. GraphQL lets you co-locate your data dependencies. In other words, your individual components can declare what fields they need, and that allows you to reason locally and move quickly. And a properly structured GraphQL app will give you data masking, which is the killer feature of GraphQL, meaning that changes to one fragment will not affect the data that another component sees. So you're truly able to work independently without sort of spooky action at a distance. And then the query is sort of updated automatically. I mean, it's basically compiled. And so there's no maintenance work that a user has to do, so it's not brittle. This is great. Isograph improves upon GraphQL and improves upon Relay by removing a lot of the boilerplate that you have to do to achieve that vision. Okay, so let's discuss that boilerplate. You're given this screen by a designer, and we're going to pretend we're building this page. We're particularly concerned about the user avatar component. So we go ahead and start writing the query. We select the viewer, we select the avatar, we select the image URL. Now, we know that a GraphQL best practice is to not select everything we want in the top-level query, but instead to extract the fields that a given function will use into their own fragment. So we replace that image URL with the spread of the avatar component underscore avatar fragment. Okay. Next, we're going to extract that into its own child component. But let's talk about the different steps that we have to go to actually do this. So first, we have to extract the child into its own file. I'm going to be very detailed here, by the way. Next, we need to pick a file name for the child component. We need to pick a component name for the child component. In the parent component, we need to import the JavaScript for the child, and we need to render the child. If this was React, that's all we'd need to do, and honestly, it's not so bad. But we're using GraphQL, so there's a bunch of extra steps. So now, on the GraphQL side, we need to select a globally unique name for the fragment. Again, not something that the user ever sees, it's just an arbitrary decision. We need to select the fields that the child component is going to use. We need to make an arbitrary choice about the prop name with which we pass the fragment reference down to the child. We need to import the type for that fragment reference in the child component. We need to include the type of that fragment reference in the props under that prop name. We need to read that fragment reference in the child component. Again, there's nothing we can do with the fragment reference other than read it, and yet it's an extra step that we have to do. And in the parent, we need to spread that child fragment, we need to remove the unused fields, and we need to pass the fragment reference using that agreed upon prop name to the child component. Okay, I mean, honestly, I think that's kind of a lot, especially if you're new to GraphQL or you're introducing GraphQL to a code base where you're going to have to do this like 200 times. But like if you've done GraphQL a bunch, like a lot of these are second nature, and you'd think like, no, we can't get rid of these. Like these steps are important. They give us something very important, and that's true. These wouldn't be best practices if they didn't give us data masking. So data masking essentially means that only a single function reads the graph data that's in a given fragment. So in this case, only the avatar component ever accesses the image URL field. And to the outside world, this graph data, it's an opaque data type. It's just a fragment reference that we don't really know. We have no information about what's inside of it. So changes to one fragment don't affect the data that another function receives, meaning that you can sort of not have these spooky actions at a distance, and you can move independently and move quickly. So this helps you scale to many engineers moving independently. Okay, so as we simplify, we'd better not lose data masking. Okay, so let's put on our consultant hat and sort of identify a bunch of redundancies. One, why are we specifying a globally unique fragment name? Like, it doesn't affect what the user sees. It's just an arbitrary choice. It has to be globally unique. Kind of annoying. Why do we have to choose a name for the prop of the fragment reference? Why do we have to read the fragment reference in the child? If there's nothing else we can do with the fragment reference besides read it, why is that an extra step? Why do we have to spread the child fragment and import the component for the JavaScript for the child component? If we're doing one but not the other, our app is necessarily broken. And why do we even have the possibility of passing the fragment reference to any other component? If we're doing so, our app is necessarily also broken. Okay, so you may ask, why? Why is it this way? And an obvious answer is that GraphQL is 10 years old. Back when it was designed, we didn't know all the best practices, and change is slow. But there's a more insightful and sort of subtle reason for this. And that's that GraphQL, as a project, considers itself a query language for your API. But we're using it on the front end to provide data isolation to our components. So it's natural that insights that are specific to the front end don't make their way very quickly to the folks who are primarily concerned with how to query your API efficiently. And in particular, one of those insights that I think the community has missed is that on the front end, every fragment is read out by a single function. Now, this may be surprising, but in a properly structured GraphQL app, this is the case. And it's exactly what data masking implies. So as we go forward, I want to take a step back and just think about, like, what would we actually want to do if we didn't have to deal with that boilerplate? So all I want to do is I want to write a function that is passed an avatar. Okay, that's pretty simple. Maybe it looks like that. So a function takes an avatar, returns some JSX element. It's not quite a React component because it doesn't take props, but it's pretty close. And this is supported in Isograph. So let's go ahead and wrap this in Isograph. Here what we're doing is, man, I should have made the font size bigger on this page. So here what we're doing is we're defining an avatar component on a field called avatar component on the GraphQL avatar type. We're telling the Isograph compiler that this is a React component, and we're selecting the image URL field. So that ISO open parentheses backtick function, that's a no-op. That's an identity function. It just tells the Isograph compiler, hey, here's some special instructions that you need to know about. Then whatever data we've read out, in particular this object with an image URL property, is passed to whatever function that follows. Okay, so earlier I said that developers write components and their data dependencies, and that dependency could be another Isograph component. So in particular, let's go ahead and write another component that uses this avatar component function. So that parent query that we had, this current user detail page query, we're no longer dealing with fragment spreads. We just directly select the avatar component, and we again wrap it in Isograph. So now what we're doing is defining a field called current user detail page on the GraphQL query type, which selects the viewer, the avatar, and the avatar component. And it passes all of that data to some sort of function. And, well, we do some React stuff in there, but what? Well, avatar component, that's a component, so why don't we render it? Yeah, that right there, that works. So that's the developer experience that Isograph gives you. So let's sort of enumerate the advantages here. One, we don't actually import avatar component. There's no imports. Fragment references don't exist. I mean, like, between you and me, what the hell are fragment references? All the types are inferred. Like, we don't have to specify the type of data, but in the IDE, if you hovered over data, it would tell you exactly what it was. We don't have to pass any data down to avatar component. It just gets plumbed. Yeah, it gets plumbed for us. It just gets passed for us. And yeah, this is what we get when we take seriously the fact that each fragment is read out by exactly one function. All of that boilerplate on the previous slides, that had to do with the fact that, like, we statically didn't know what function was going to read a fragment, so we had to sort of help pass it along to the right function. But given that only one function is ever going to read one fragment, we can do a lot more if we just encode that assumption into our framework. So that's why I'm going to say that client fields, Isograph's central abstraction, which again are functions from some graph data to an arbitrary value that's then exposed, that defines a new field, are, for GraphQL on the front end, are GraphQL's missing primitive. These client fields, they unify a bunch of seemingly disparate concepts. We'll go into that more later, and allow us to draw connections between things that would otherwise, you know, only look superficially the same. Okay. But those fields that we defined on the previous page, they're not really doing much right now, right? At some point in time, we need to make an API call to fetch the data for a given page and somehow start rendering this. In other words, we need to go from like React land to Isograph land. So how do we do that? Don't worry about reading this, it's not particularly insightful. But to do that, what we do is we define an Isograph entry point. So on that third line, there's ISO entry point. That instructs the Isograph compiler to, among other things, to generate a query that when executed will fetch all of the data for the current user detail page component plus all of its subcomponents. Now, the network request, it won't contain any client fields. It won't contain avatar component. It'll just contain the server fields, because client fields are obviously a front-end only phenomenon. So what happens here is this function will render. When it renders initially, it will make an API, will make a network request for the data. When we attempt to render detail page, the data will be missing, so it'll suspend. The network request will complete, and we'll try to re-render, and this time the data is present, so we'll go ahead and render the page. Okay, so let's review. At the root, you connect your Isograph component to React using something like this, and then it's all client fields all the way down, and then they bottom out at server fields at some point in time. Okay, so I mean, honestly, I think that's kind of a nice experience. But yeah, I want to spend some more time talking about the advantages of client fields, which is to say, no, I've already defined client fields a bajillion times, so we're good. Okay, so one thing it gives us is data masking. In particular, only one function reads a given fragment. It's sort of like structurally baked into this. This means you can reason locally, and changes to one component don't affect the data that another component receives. Okay, I mean, I hear what you're saying. Relay also gives you this. And what I really should have said is not data masking, but we have data masking without the boilerplate. If you're building a properly structured GraphQL app, you're using client fields, you just don't know it. And you're not using it very cleanly. You're using it with a lot of boilerplate. Okay, so next, if you defer the data for a particular component, the data used by a particular component, a good default would be to also asynchronously load the JavaScript for that component. Now, Isograph doesn't support defer, but when it does, that will be its behavior. In other frameworks, it's inevitably going to be two separate steps to asynchronously load the JavaScript for the avatar component because there's no static connection between the component and the data it uses. It's super coincidental that the one component happens to use that fragment. Even though, I mean, that's probably a best practice and most likely what you intended to do. Next, consider client field components. Isograph is the only framework in which it makes sense to ask, like, is the data on screen? I mean, is data on screen? That question doesn't make sense. Data does not have a spatial location. But because the data is statically associated with a component, we can actually ask, is the component that uses this data on screen? And so we can get insights like, hey, the footer during the initial page load is always below the fold, so let's go ahead and defer the data for the footer and asynchronously load the JavaScript. That's the kind of insight you wouldn't be able to get in any other framework. Okay, now if defer wasn't just load the data slightly later or now, but also included a third option of load the data when I say so, we could do more clever things, like maybe start loading the data for the footer and the JavaScript for the footer when the footer is 600 pixels from being rendered on screen as you scroll down. So imperatively loading JavaScript and data at a future time. Did somebody say relay entry points? Now, defer and entry points can be used to delay execution, but can we speed it up? And yeah, client fields that are pure functions, well, why don't we just execute that code on the server and send the results down in advance? Did somebody say React Server components? And if we don't send down the JavaScript for these client fields, but just send down the results, well, we're just basically rediscovering regular GraphQL resolvers. Okay, so we've seen that client fields allow you to control when and where execution happens. But what about what? Well, a parent component, I mean, if you think about it, it doesn't really care what concrete value it gets for a particular dependency as long as that dependency matches the correct contract, which is to say it has the right type. So what I'm saying is that client fields are a vehicle for dependency injection. So you might imagine if you're bundling for mobile, then the current user detail page, the avatar component that it receives will include an avatar that's 16 by 16 pixels. But if you're bundling for desktop, it'll include a higher res version of that avatar. Or if you're bundling for a unit test, well, the avatar component, maybe it's just a div with a data ID attribute. Okay, so enough about that. Let's talk about dev tools. So GraphQL claims to enable really powerful developer tools. Client fields are new fields. Wouldn't it be nice if when you loaded Graphical, you saw, in addition to all the fields that an avatar has, like image URL, you also saw, hey, there already exists an avatar component in your code base. Just ask yourself this, how many redundant user avatar components are there in your code base? And if your IDE or Graphical suggested to you, hey, there already is one, maybe some of that deduplication could be cut down on. Okay, I'm going to prove to you that Isograph is not vaporware. Let's take a look. Okay, how do I do? Okay, so now I have to stop mirroring. This is the tough part. Main display extent mirror. Yeah, okay, cool. Awesome. So this is a, let's just say pet phrase card, pet summary card. Okay. So this is an actual Isograph project It's one of the demo projects in the repository. So what we're doing here is we're defining a field called pet summary card on pet, and it selects these fields here. Favorite phrase loader is another component, and these are all like sort of regular fields. So now if we look at this, you see that we have this data prop, which is not typed. We don't explicitly provide a type, but if we look at this data dot, we see that we have all the fields that we actually wanted. So in particular, if we do something like, I don't know, take away name here, then, and if the compiler is running, I actually don't know if I started the compiler. What is this? Yeah, I think it's pnpm watch pet demo. Okay. Yeah, so now if we remove name, we start to see that we have a compiler or a TypeScript error saying like, hey, this name field is not present. Okay. So the next thing I want to point out is that every single Isograph literal that defines a field results in a generated file. So for example, here, if we look at pet summary card /reader, I kind of have to zoom out for this. We see that we have this reader AST file here, a reader AST object, which is what is used to actually read out the data. So what you'll notice is that name is not here. And also, name does not show up on the types. So like, even if there was another component next to this component that selected the pet's name, this actual component would not receive the name at runtime. So what's cool about this is that, you know, we can, yeah, so if we go to like favorite phrase loader, actually I don't want to talk about that one. That was not interesting. Let's do pet updater. Okay, so another thing we want to talk about is like mutations. Mutations are a notoriously difficult thing in GraphQL. So if we look at the schema, you'll see that we have this set pet best friend and set pet tagline field on this guy. And we go to the pet updater, well, we're also calling set pet best friend, but that doesn't appear on the pet type. That actually appears only on the mutation type. So what Isograph supports, if you go to schema extensions, is this directive expose field, which tells you that like, basically, we're exposing the set pet tagline mutation on the pet type, and we're remapping sort of the ID, the pet's ID, to the input.id field here. So what that means is that if we go to the pet tagline here, when we call set pet best friend, and we call it, we don't actually need to pass any IDs. It just automatically infers that because we selected this on this particular parent, on this particular pet, we get the correct pet ID passed to the backend. Okay, so just like with any other mutation, we need to select a bunch of fields to determine what we get back. Okay, so I go, oh wait, I'm actually not selecting any fields here. Interesting, so what do I get back when I call set pet best friend? And the answer is that if we look at, let me see, it's probably refetch 0 or something. Yeah, set pet best friend. This is a generated file, so it's not pretty. It actually selects all the fields that are otherwise selected on that pet in that location in the query. In other words, if I go here to set pet best friend and I remove potential new best friends, and I save, well then potential new best friends stops getting selected in the mutation response. And this isn't just in the one component that actually use that mutation field. It's all the ones that are in the merged query. So that means that like if you have a update pet mutation and somebody else adds a component somewhere else such that they merge to the same pet, your mutation response will automatically contain the correct data. So you're always going to have essentially consistent results in your, you're not going to have missing fields if you change the best friend and don't select the right things. Okay, so why don't I actually just show you that that's a thing. So this is actually what we're looking at. This is the pet. Oh, I have some garbage data in here. What? No, you guys. Oh, you know what? That's because I stopped selecting set potential new best friends. Okay, cool. So like if I fix that and then I refresh, it's fixed. It works. So actually there was a type error belowhand that told me that that was wrong. I just didn't scroll down that far. So here, if we go to take a look at the network response and we update the best friend, you'll see that the GraphQL field, oh, I think I have delay. Yeah, I'm delayed right now. That's why it's so slow. You'll see that the query contains all the stuff that we need, and the response contains a whole bunch of stuff, that we selected. It's all automatically generated. Okay, so that's sort of enough about the runtime here. Let's talk about the Rust compiler. Okay, so the reason you guys are all here. Okay, I subjected you to enough JavaScript. Okay, so at a very high level, what does the compiler do? When you run it, it parses the GraphQL schema. It scans your code base for ISO field and entry point literals, and it generates an unvalidated in-memory representation, which we're going to call an Isograph schema, which contains all the info on the fields and entry points that are available or used in your project. Next, it goes ahead and validates this in-memory schema. So in particular, the Isograph schema is generic, and it's generic over the types of pointers that it uses. So in an unvalidated state, the pointers are all strings. Like I attempt to select the pet name field, well then that's just represented as a string. And the process of validation is simply mapping over each of the fields and entry points and so on and so forth, and looking up all the strings to make sure that they actually point to something that really exists, and replacing them with IDs, which are indices. So, for example, the query.currentUserDetail page, in an unvalidated state, it's represented as a tuple of a unvalidated type name and a scalar field name. And because that points to a single field, after we've validated it, we look up, like, does this type name exist? Does it have a scalar field named currentUserDetail page? Then it is replaced with a client field ID, which is, an ID. So after we're done validating, we go ahead and generate a bunch of artifacts. So there's 4 types of artifacts. There's entry points, reader artifacts, refetch/mutation artifacts, and iso.ts file. So starting with entry points, we generate 1 per ISO entry point literal. And this guy, most importantly, contains a generated query text for all the fields that are used by that field and all of its subfields. But it also contains a normalization AST, which is to say a data structure that tells you how to write that network response into the Isograph store. And it references a reader artifact. So that reader artifact, there's 1 generated per ISO field literal. This contains a reader AST, which is the data structure that's used to read out a field's dependencies. So like we saw earlier, that's what ensures that the pet component only receives the field that it specifically asked for, even if there's a sibling component that fetched other fields, and there were other fields in the network response. It contains the TypeScript types of the read out data, and it references the exported JavaScript function that is our sort of Isograph literal. So in particular, we need to know what's the function to which we have to pass the data that we read out. And it references the reader artifacts for any nested client fields. So that's how, when we defined the current user detail page and selected avatar component, we never had to import anything. It was all sort of done for us by the generated Isograph generated files. Actually, one thing I forgot to include in this presentation is that there's a Babel transform. So when we go here, entry points, when we encounter this, there's a Babel transform that replaces this with a require call to the generated file. So this gets, at runtime, gets replaced with something like require isograph / query / homepage / entry point. So you don't even have to do any imports even here. Like there's a Babel transform that does all that for you. Okay, so refetch artifacts and mutation artifacts, those are just really similar to normalization artifacts. There's a query for the data that we need. One thing that's pretty cool is this iso.ts file. So here, we always import iso from this special location here, this from @iso. That is the iso.ts file. And there's one generated per project. It contains overloads for the iso function. And in particular, it's how we achieve type safety for our fields. So it's going to contain a bunch of things that look like this. So basically, the iso function, if it's passed a string that starts with field avatar.avatar component, TypeScript knows that the type of that iso function at that point in time is essentially a function that takes these params. So that's how data.imageURL, like you can get autocomplete for that, and you get type errors if you select a field that doesn't actually exist. And on every save, this iso.ts file is regenerated. So this is an example of just hovering over that data field for something in the demo. Okay, so a compiler uses a lot of strings. Strings are expensive. So one thing that we do, instead of using strings directly, is we intern all of the strings. So in particular, that just means that we push them onto a vector, and we replace the string with the index in that vector, to which that holds the string. And not only do we do that, well, so that's nice because now we can feel free about, now we can copy them everywhere. We mostly don't need to do mutations of strings, so like we don't ever need to worry about that. And they don't take up much space. We can use them willy-nilly. Next, all of our strings are wrapped in new types, which is a sort of a Rust pattern for zero-cost abstractions to say like, hey, even though the underlying data type for this string and this string is the same thing, they're both U32s, they're actually different types. So the purpose of a string is encoded in the new type. So for example, we might have a scalar field name and a selectable field name, where if when we read a string for the first time, it happens to be a scalar field name, we know like, hey, we're going to mark this as a scalar field name. And we also have allow lists of different typecasts. For example, a selectable field name is either a scalar field name or a linked field name. We allow list the fact that you can always convert a scalar field name to a selectable field name. And it is more difficult to go the other way, which is essentially just a way to force the developer to be a little bit more careful, because what they're doing is less likely to be automatically correct. And this is how it's done. It's just with a pair of macros. So there's one to define a scalar field name, and one to sort of allow list the conversion from scalar field name to selectable field name. Okay, so far we've just been talking about batch mode, which is to say the compiler does everything, generates a bunch of artifacts, and stops. Isograph has a very basic watch mode, which just reruns the batch compiler whenever any file changes. I would like to make it more efficient by adding incremental recompilation and stuff like that, but all in due time. Okay, I guess the last thing that I wanted to show is that there's actually some pretty cool errors that are displayed in the thing, in the terminal. So if we select a field that doesn't exist, and we go here, we actually have these quite nice, I think, errors here. It says like error when validating in the client field, but that field does not exist. And then it sort of tells us where we did that. That's kind of cool. I was a little proud of myself when I made that. Okay, so the TLDR is that developers write components and dependencies using Isograph literals. The compiler finds these Isograph literals and generates files, and the runtime uses those files to give you the developer experience and the app experience that you want. So what's next for the project? Well, one, I want to get runtime feature parity with Relay. There's a lot of stuff that's just not implemented, but it's all on the roadmap. JavaScript, React, and GraphQL, they should be implementation details. Like there's no reason that I can't generate Kotlin code or Swift code or Vue or Svelte or Angular components, and nobody actually really cares that we're using GraphQL to hit the backend. Like there's no reason I shouldn't be able to generate SQL and you make a network request with some SQL string. In addition, like we discussed that the server should be able to execute certain fields. So we need to be able to teach the server about certain resolvers. And there's a lot of stuff in the tooling category that needs to be done. VS Code extensions, that graphical stuff. Yeah, that's what I got. I mean, like, if you want to get involved, like, I think now is a great time to help out with Isograph. It's pushing the boundaries of what's possible in app development. And, like, you're going to be able to get in and do, like, real foundational work. And if you want, like, a lot of leeway or if you want a lot of support, either way, like, I'm happy to provide it, happy to provide you the freedom, whatever you need. Yeah, that's Isograph. So.
Let's try this new thing for the questions. Just raise your hand if you have a question. I'll come to you and give you the mic. All right, Brian.
All right, this is kind of a can you hear me? Is this working? Is it? Okay.
It's going to be on the recording.
All right. So maybe a slightly long-winded question, but I've used similar frameworks before that kind of allow you to define some configuration in a string, and I've always felt a little bit dissatisfied about the developer experience with those because once it's in a string, I'm not getting any feedback from my IDE about it. One of the things that's great about, say, JSX is the fact that it fits right into, it's not in a string, right? So I can get feedback from my IDE. Have you thought about this issue, and do you have any ideas about how you can bring a JSX-like experience to this kind of system you have here?
Yeah, absolutely. So 100%, Isograph needs a VS Code extension that provides things like go to definition and find all uses of this field and surfaces errors directly in the IDE that tell you like, hey, this field doesn't exist or this or that. So yeah, the answer is yes, it needs to happen. I actually worked on the Relay VS Code extension when I was at Meta. So a lot of what I'm going to do is just like wholesale copy what I worked on there. It's all open source, so like, it's going to happen. Yeah, and it needs to happen. So.
I'm kind of curious what the biggest hurdle you had with the compiler, just personally, what was the hardest part you think in this specific problem?
I think I guess two things. One is just organizationally, just getting started on it was kind of, it felt daunting.
Yeah.
But I guess all the individual parts are somewhat easy. So once I got a version out, it was fairly, then progress really picked up. I think the most conceptually difficult thing is managing all the different types. Mm-hmm. I mentioned with validation, at first the unvalidated schema contains essentially string pointers everywhere, but it's actually generic over 6 different types. And so as we map these over, it's kind of sometimes hard to reason about what state exactly are we in and what's the ideal sort of way to do validation. Mm-hmm. So there's a few cases right now where if you make an error or if you reference a field that doesn't exist in these mutation, in the expose as directive that exposes the mutation fields, it'll panic because it really should be in a more validated state when I do that, and I'm letting it panic because it's sort of an indication that I need to fix this, rather than emit an error here. So I think that can be a little bit hard to reason about, and I had something else in mind. I don't remember what it is, but I think those are some of the hard things. Yeah.
Sorry.
Go for it. Yeah.
So I have two questions actually. First one would be, before you started the project, how experienced were you in writing Rust in general? How much Rust projects did you do before you actually, because this is, I assume, quite a complicated project. It has some tricky bits, I would imagine. The generic stuff would probably make a beginner cry. And so that's the first question. The second question is, if you have any, I would like to see some sections of code maybe that you're particularly proud of or that you think are pretty cool. That would be interesting to me.
Cool. I have about 3 years of professional Rust experience before I started this. And I think the most relevant experience was not necessarily the Rust. Like, there's complicated Rust stuff in here, sure, but it's more that, like, I worked on Relay, and so, like, a lot of the concepts are, I understand the concepts right off the bat, and understand, like, because, like, I'm doing a bunch of generation of JavaScript and stuff like that. There's no, like, not really any type checking of that. I just have to, like, intuitively understand, like, what's the right thing to generate. Code that I'm particularly proud of. That's a tough one. Let me think. Yeah, let me see. Yeah, actually, I mean, I don't know. Maybe the batch compile function is pretty decent. I think it's kind of cool that, like, it is somewhat straightforward once you call a handle compile command. In that, like, we literally just read the schema. We parse the schema. We parse a bunch of extension documents. It's not like the cleanest code because I'm just, like, you know, optimizing for throughput rather than cleanliness. We create an unvalidated schema. And then for each of the objects, we sort of, like, process, like, mutate the schema with it. And then we add the magic mutation fields. And then we read the files, and we extract the literals, and then we process each of those. We add fields to subtype. I mean, I just kind of like that it ends up being more imperative and straightforward than you'd think, like, oh, a compiler. Like, it's you know, it's a fairly simple compiler. And then it does a bunch of stuff to generate and write artifacts. Yeah, I don't know if there's anything I'm particularly proud of more than the rest. I'm sorry. I'll think of something. So, yeah.
Somebody had a technical question over here.
It's a non-technical question, I'm saying. It's a non-technical. My question is, so you left Facebook. What is your sort of organization? Like, are you a startup now, or is this a hobby project, or what's the roadmap of this project, and what's your plan to sustain it or turn it into something that makes money?
Yeah. So I'm currently at Pinterest, and I'm helping them adopt Relay, which is what I worked on at Facebook. And I have been working on this on sort of nights and weekends. And my intention with this is to, within a year, make it a legitimately good choice for companies to adopt. And I mean, I don't know if I want to necessarily make money off of it. Like, I think I get a lot of non-monetary remuneration by, like, being able to speak about it and things like that, and, like, meeting a lot of cool people and having a reason to reach out to anybody on Twitter and, like, you know, not feeling awkward about it. So there's that. But, like, conceivably, if I were to build a business off of it or something like that, presumably it would be more, I would start by consulting and then try to build something that's sort of self-sustaining. But that's, you know, that's putting the cart before the horse at this point in time.
Yeah. Oh, thanks. I have a friend who might be really interested in this, but that's the first question he's going to ask is, what's the future? Like,
oh, excellent. Yeah, I'd love to talk to your friend.
How stable is this going to be? Like, is this still going to be here in a year?
Yeah. Well, the answer is yes. It's going to be here in a year.
You said that, like, a lot of this is very imperative, which is kind of surprising. I kind of imagine that a lot of complex compilers, because they have to do some sort of, like, should I say, like, optimizing algebra or something like that, rather than just, you know, doing translation from one language to another, you know, as simple as it can be, like syntax-directed translation, right? Like, where in the grand, you know, gradient of all that do you find this compiler to be?
I think it does not a lot of, it doesn't do a lot of, like, transformations or anything like that. And it's probably going to remain on the simple side until it, like, actually we have some sort of imperative language that you can encode in the Isograph literals or something like that. I think that complexity that will need to be added on is to make this more of a, instead of a batch mode compiler, more of a pull-based compiler, to be able to do stuff like incremental recompilation. Like right now, batch mode is just like, I mean, watch mode is just like redo everything from the start, which is super wasteful, but whatever. And ultimately, like, I want to be able to, instead of doing everything from start to finish, have something like a large tree that says like, hey, the iso.ts file, its dependencies are all of these things. So like when I need to when this thing changes, mark everything up the tree dirty, and then just recompile the bits that need to be recompiled. But I haven't done that yet. That's something I'm going to do at some point in time, but it's not a super high priority. So.
Thanks. I'm curious about how to organize the ISO literals. So I've noticed that the ISO literals are scattering among different files. So I'd like to see how can I put them into separate files, and maybe you know it's going to be painful to maintain the scattered ISO literals later. So the demo project is a relatively small project. So when the code base grows bigger, this might be some burden. Yeah.
So with Isograph literals, like where they are located doesn't matter. The compiler sort of understands like how to make relative paths. So if you look at, I don't know, just some random reader, pet updater, it knows how to import everything from whatever file it happens to be at. So like however you want to structure your code for your project will work with Isograph as long as it's within a folder that Isograph knows about. So do whatever's best for your project.
Okay, I see. So
Yeah.
so maybe we can also use use the path information to make it more structured.
Yeah.
Like the parent component is in a folder, and the child component is under that folder, and this information could also be utilized by the compiler.
Yeah, I mean, you could do that. If you wanted to structure it that way, you totally could. One thing that's cool is like, it just kind of works. So like, if we, I don't know, make an ASDF folder and move the pet detail route into here, yes, update all the imports. And then the compiler reruns. Oh, I still have that ASDF thing. If we get rid of this guy, it compiled, and like I moved it to another file, and it will just continue working. So yeah, so you can just do whatever you want. The compiler understands the relative paths. So yeah, like 100%. If you wanted to do that, I'm not sure what. Yeah, and like also like if there's some benefit to encoding the fact that parent components are in a folder above and child components are below, like we can certainly extend the compiler to like make use of that information.
Okay, I have another question.
Yeah,
so
go for it.
Hold on, one question at a time.
okay.
I'm gonna throw it to you.
My question is very simple. I'm just wondering, because I was in the other room, is this already open source, and then are you looking for contributors?
Yes to both. So you can go to the GitHub, which is Isograph Lab/Isograph, to find the repository, or you can go to isograph.dev to see the website. And yeah, 100%. Would love for anybody to contribute in any capacity. As much freedom or as much support as you need. Like now is a great time to contribute because like there's still sort of foundational work that needs to be done. And we have a pretty long backlog. So yeah.
Thank you.
Yeah.
There we go.
Thanks. I have another question.
Please.
So, are you just using the Relays compiler or just GraphQL compiler to compile these ISO literals, or you have to customize that?
I did not use the relay compiler for this. I like the intern strings is a package that the relay compiler exposes, but overall it's just like a re-implementation of it. And the reason for that is that I wanted to add more type safety at like a lower level in the compiler, and like a lot of things that I just wanted to make different decisions than the relay compiler makes, in terms of like having the schema be generic over different types and stuff like that.
So you rewrote the parser.
Yes. Yeah.
Okay. Thanks.
Yeah.
Yeah.
Yeah, because this isn't valid GraphQL. Like, right? It sort of looks like this part looks like valid GraphQL, but like in the end, I want to add stuff like the ability to add different syntax features. And like these exclamation points like would essentially do stuff like what @require does in relay.
So is it a LALR parser or something?
It's a LL1 parser right now.
L1. Okay.
Yeah,
okay.
yeah.
Thanks.
And I want to keep it that way. Like that makes it a lot easier to
Yeah,
reason
yeah.
about. So
Okay. Thanks.
yeah,
That's all.
cool.
I have some newbie questions, unless anybody else has questions.
Go for it.
You don't have a question, Remy?
No.
Can you please go back to, actually, this is great.
Okay.
It was on also slide 23, but okay, my bad. I can't, not that close. So I'm not really knowledgeable about JavaScript, TypeScript. So is this thing like a valid piece of TypeScript?
Yeah, this just defines a string.
Oh, interesting. So it's just a multi-line string from
Yes. Yeah.
the tick mark to the next
Yeah.
tick mark. Gotcha.
Yeah. And if it encounters templates, it's gonna the Babel plugin will throw an error, I think. At least it should. And also, the Isograph compiler will probably panic if there's any, because it doesn't know how to deal with dollar signs. Yeah, but like you can do stuff like this. And if you do this, and it will. Oh, hey, it didn't panic. Okay, yeah, that's pretty cool.
Maybe it should.
Yeah. Yeah. Well. But yeah. So it is valid. It is valid syntax. Yeah.
Does anybody else have a question? No? Okay, then I'll ask my Remy.
I'm just thinking of questions. So I'm not
Okay, no pressure.
So like, how does the compiler it's reading through this JavaScript file or a TSX file, and I guess does it use like the ISO function as like the key
Yes.
to let it know that this template string is going to be what it needs to compile from?
Yes. It's probably. Regex new maybe. It just looks for this. This is like not the prettiest, but like it looks for that, and what's kind of cool about this is that like you can export it as anything. It doesn't really matter. It understands it. I will just need to add support for default exports as well to allow you to export default things, and it'll just work. But yeah, like a slightly more performant version of this would probably be like look for the character I followed by the character S followed by the character O instead of a big ol' regex, but like it works.
That's what regex is doing.
Yeah, well that's true. That's true. Yeah. So.
Can you please go to slide 49? I had a question
Oddly
about
specific.
it, but I don't remember what it was, so hopefully I'll remember if I see the slide.
Yeah. This one?
Yes. So again, I don't know anything about TypeScript, but this looks kind of like what does this?
Yeah. Okay. So let me
That's
show you
like
the
a type
actual
bound.
thing. Yeah.
I need to back off.
So this is the generated file here. I actually renamed the type in the slide because I'm to simplify. But basically, it's saying that like if we encounter the ISO function and it is passed this parameter, then the return type is this. So if we go to let's see, if we go to this thing, we're calling this ISO function here, and so the type of this thing on the left side is this, ISO with param component or something like that. And so what are we doing here? One, ISO with param component, that's pretty simple. That just says it is a function that takes some data and returns. I mean, it's an identity function here, and except that we have bound the type of the first parameter. So we know in advance that the first parameter to this identity function is whatever we said it was, in particular like an object with like an image URL field. Okay, so the other thing that we're doing here is we're saying that this param is this matches white space and string thingy here. And so matches white space and string is something I do not understand at all, but it is it is this type here that says as long as there is only white space before this string, then it matches. And how did I figure that out? By a lot of trial and error. And it works. So
this is some sort of like runtime type trickery?
No. It's a recursive type that TypeScript understands that basically, so like if we do this, right? Let me see this.
So what's the semantics of this thing? Sorry, again,
You're
like,
good,
what
you're
does it mean?
So if we have type foo t equals this thing, right? So const x foo. Wait, why do we have t here? Where's the t got to go?
It's at the end of the matches white space and string,
yeah.
I guess. There you go. So that needs to come from somewhere.
Yeah, but how do I? Okay. So this should. Let me see. Actually, I'm not really sure how I'm going to have to do this. So basically, the first ISO overload that matches this white space and thing, that matches this, is the one that TypeScript chooses as its type. So actually, I had to, in this case, like, I had some bugs where like a shorter field, a field with a shorter name came before a field with a longer name, and so the longer name field was matching with the wrong one. And then I had to just reorder it by like sort of length of, by length. Does that, I mean, yeah, I mean, it's a recursive type that tries to match like a bunch of white space characters followed by
Type level.
followed by some string. Yeah.
Concatenation.
Yes.
Stuff.
Yeah. Yeah.
Pretty wild.
Yeah. I do not understand it very deeply. So, but it works.
Any other questions?
I guess this would have been good. This would have been good. A good answer to your question earlier. Like, what am I proud of? Like, I think it's pretty cool. Yeah. Yeah.
I don't want to say I would disagree.
You're not
missing vertical tab.
Oh, how do we specify that? Like, what even is a vertical tab? So, yeah. So.
The nice thing about stuff like this is people see this, and then no one is able to say that Rust is complicated because they look at TypeScript type inference, and then everything else just looks pretty easy.
Yeah, TypeScript is way more complicated than Rust, I think. It's just like super hard to reason about. I don't like it. So.
That's Microsoft for you.
Hey.
Still better than JavaScript, though.
No.
All right. If there are no other questions, then we're gonna wrap up because we're about time here.
Sweet.
Thanks, Robert.
Thank you.